Okay, we're back, and it's COMP123. It's week 6, lesson 6, part 2. And we talked about, before the break, we talked about these properties and instance variables. In the book, as you can see, the public properties are capitals, the instance variables are lowercase. And for our convention here, just so that we're on the same page, we're going to use this underscore in front of the private properties. Okay. This is talking about parameters here, and again, I can call them parameters as well. There's auto-implemented properties. Again, we talked about this as well in terms of using this. Here's an example of auto-implemented public properties, right? They're right in your book, right? And what this does is they're public properties with a standard getter and a setter, right? That's what auto-implemented properties are. And that's a difference between this here. That's what they're called, auto-implemented properties. They're different than the standard, the custom properties we created with a getAccessor method and a setAccessor method. Let me just go forward a little bit and peek through. So here's a couple of examples just to recap. Public int length capital L, and then private int length lowercase l. This is your private instance variable. This is your public property with two methods, getter and a setter. And if you notice, they do something in the setter. That's the advantage of a setter and a getter. They have a code block, so you can do you don't just set it, but you also can create. You can also set other things in here. Like for example, you can call this calc area method, which is a local or a private method down here that calculates the area. So you can do that as you're setting the length, right? So there's some advantages to using getters and setters as opposed to straight instance variable assignment, right? If I was ever going to make an instance variable public, then I would do it with automatically generated getters and setters, just to keep with the convention, okay? Or auto-implemented property is what I would use. Okay. We talked about this reference. I'm moving on from this one. So I think we've covered the majority of what I want to talk about with properties. Now you guys know what properties are. And we've already used constructors, parameter constructors. So I just wanted to kind of hit that. Okay, here's the next part. Things we missed. Abstract classes. So we talked about classes, right? And the difference between normal classes or concrete classes are that you can instantiate a concrete class, but sometimes there's a call for making an abstract class, right? A class that never gets instantiated, but is only a shape, if you will, or a blueprint for other classes. We talked about classes being blueprints for objects. So abstract classes are blueprints for other classes, and they're never instantiated, okay? They're never created into an object. So abstract classes, again, you cannot create concrete objects, right? But you can inherit from them. That's one thing you can do, right? And sometimes, usually but not always, they contain abstract methods. But although methods in general are not required. Let's give some examples of these things. Here's a class called animal. We talked about this before really briefly, right? The class animal is an abstract class because we're using the abstract keyword. That's what makes it abstract, okay? So this class animal can never be instantiated because from a business rules perspective, you can't say, well, you can say it's an animal, but normally you want to say if it's a dog or a cat or a mouse or something else that's kind of considered an animal, specific type of animal, right? Here we have a couple of talk about properties of the class, this abstract class. We have a private instance variable called name. We have a public property, right? It's very interesting. This is our public constructor, a constructor that it takes in the name with using constructor notation, sets the name, the private name. That's also fine to do, right? So again, there's two ways to set with proper conventions to set instance variables. The first way is to use properties, right? Public properties to set instance variables. The second way is to keep the instance variable private, but to set it one time in your constructor. All right, so you set it in the constructor. You send it into the constructor after the new keyword. So your example would say, if animal is something that could be instantiated, which it cannot because it's an abstract class, you would say my animal is equal to new animal. And when you did that, you would pass in the name of the animal. Okay? But in this particular case, we can't because this constructor is only for the inherited classes that come from this abstract class. We'll get back to that in a second. I also have a getter for my name, which is a read-only property, right, with name capital N, whereas this name is lowercase n. Okay? Here's our getter, our getAccessor method, right, as an example. And this is something that we have in our abstract class. Here also is something else. We have a public abstract string, a return string called speak. And what this does is it actually lists a method but doesn't define the body of the method. Why are we doing this? We're saying, hey, if you implement a subclass of the animal class, you have to include a method, right, called speak. That's what we're saying. We're forcing all subclasses of the animal superclass, right, to have a method called speak, but we're not defining that method because we're labeling it as abstract. Okay, that's why we didn't cover this at the beginning. Covered it one time, I kind of skimmed over it. I'm coming back, circling back to this kind of stuff, because if you guys don't understand classes, now when we start talking about this is really hits into polymorphism and inheritance, right? And I don't really want to talk too much about this until we actually need to do it, which is now. Okay, so here's some examples of some subclasses of the animal superclass. I've got a dog, right? A chihuahua, no, a dog. And it's got a public, here's my public constructor, it's called dog. It also must take in the name of the dog, right? And I also have to call the superclass the base. I have to call this my superclass constructor by using the base keyword and pass in the name of the dog so it goes into my superclass. Okay, I also must override, right, the speak method that was defined or mentioned in my, let me just run this thing for a second. It was mentioned here in my animal superclass. I have a speak method right here, but I haven't defined what it is. But I'm telling my subclass that it needs to include it and override it. When I use the abstract keyword, you must override this method or else it won't work. Yes?
That doesn't go the same for the class, the abstract keyword.
The abstract keyword, you don't have to instantiate a class of this thing, but once I make a subclass of an abstract class, it has certain things, certain properties and methods that I must override, right? Here's one of them. Public abstract string speak. Okay, so I've got a couple of them. I've got a couple of subclasses. Animal is my superclass. Dog is my subclass. Cat is my other subclass. They're both derived from the animal superclass. And look, I have to define a code block for my abstract method speak that I briefly mentioned here in my abstract. So my abstract class, blueprint, a really, really high level for my subclasses that come from it. Okay? Again, more of a challenging concept for most beginning programmers because they're like, and why do I need an abstract class? I don't understand. Why don't I just flesh out a class and who cares about abstracts? Well, the advantage to abstract classes is that you can create a class that other classes inherit from. So if I want to change both my classes, my dog and my cat class, right now I only have a speak method. What about a run method? They're going to run, right? Or walk or some kind of thing. I can add this method, a requirement, into my abstract class, and then the other ones will inherit it automatically. Both classes. But they'll have to both override those two methods, right? So it forces the animal to have a shape. It forces you to have, when I say shape, it has other existing components to the class. One of them would be the speak component. It's a method that's part of the original abstract class. And when I use the abstract keyword, I force any users of my abstract class to create this speak method or to define the speak method in their subclasses. That's all I'm doing.
Excuse me.
Yes.
When you use the override keyword, what's happening there?
When I say override, right? I've just defined. Let's do an actual example here. Let's do another one because I can't do it within this I show you. Let's leave this one alone, right? I'm going to save this one. I'm going to create a new project. File, close, solution, right? I'm going to do a new one. We'll do the whole animal thing again. File, project. Here we go. I'm going to do a new console application, and we're going to call this COMP123 Lesson 6 Part 2. All right, Part 2. Here I am. And inside my GitHub, just for those people who are interested in following along, right? I like your question, by the way. I'm going to create a new repository called COMP123 Lesson 6 Part 2, right? And inside there, I'm going to grab my URI, go back to, no one needs to see my schedule, go back to Visual Studio, see what happens when you have multiple things going on, and when you're sick, it's bad. I'm going to go to Changes, I'm going to say Created Base C# VS project, Visual Studio project, something like that. And then inside unsync commits, I'm going to pass in my URI and press publish. Yay! Let's do this. So let's create our animal class. I like the example. It's a nice example. We could also call it a vehicle class, right? But I like the animal class because it's in your book. So let's go new item, and inside there we're going to have a new class, and the class is going to be of type animal, right? Okay, here's my animal class. But this class, right, if you notice how the examples go, oops, not that one. If I notice how the examples go, actually that's okay. If you notice the class itself, it has the abstract keyword in front of it, right? That's the keyword that I need. If I put the abstract keyword in front of my class, automatically the compiler knows that this animal class can never be instantiated. You can never create an object of this animal class. It's just a blueprint for other classes, right? Okay, we have a private property, right? So I'm going to put it in there, private, and it's going to be of type string. Hey, it's a private property. I'm going to put an underscore because that's me, right? And it's going to be name, lowercase, right? So here's my private string property, and I'll put that in there, right? Because we're gonna call this private. So private instance variable. Sorry, right? Here, private. I could make public instance variables too. Bad program, but bad practice though, right? We've done that in the beginning, and we did that in the first 2 assignments, and never again. Okay, just letting you know, right? It's not the way we're supposed to do it. Okay, but you have to know how to do those things too, because you'll see it in code out there everywhere. And you're like, hey, that's bad practice, right? But at least you'll see the difference. Okay, cool. And now I need to make a public. So here's my public properties, right? Public properties. And the only way that I can, I want to make a read-only private property for my name. So I'm going to say public, right, of type string, capital N for name, right? I'm going to surround it in braces. I'm going to use a getter, right? And inside my getter, I'm going to return, right, this dot underscore name, right? That's my public property, and it's going to be, of course, read-only. I'll kind of say read-only just so that it reminds you. This is only one. There's no setter, so there's only a getter. That means it's a read-only property, right? Okay, cool. Private instance variables, public properties, and now I can define my constructor for my animal, right? So public animal, right? And my animal is going to take in name. So a string name, right? You're going to see this. And of course, this dot underscore name is equal to name. And we know the underscore means this, we're assigning my instance variable this local variable name that comes into the constructor. When it's in here, right, any parameter that comes into the constructor is a local variable that lives and dies in the constructor, right? So that's why we have to assign it to our instance variable right here, okay? So far so good. Let me just go back so we can see that. Same, right? Here's the rub, right? Here's the rub. I have my public animal constructor up here. They put their public property down here. I like the other way around, just from a convention perspective. I like to do all my instance variables and properties on the top, and then my constructors, and then after that, all my methods. Here's a method, but I have no body for the method. Let's look at that. So here, let me just kind of put that in there. So I'm going to say constructor. I'll put constructor, because I only have one right now. It could be more than one. Right? Remember, I can have overloaded constructors, right? That means more than one constructor. Okay, and on the bottom here, I want to put a new method. So here is I'm going to call them abstract methods, right? Now, by nature, because I'm making a method that I want to be overridden, I have to make it public. If I make this private or protected, right, it's going to cause an error. You'll see what I'm talking about in a second. Let's try this. So if I say private abstract, and I call this, it's going to return a string, right? And it's going to be called speak, like this, right? If you look at this, why would I make a private method, right, that's called speak? It never can do anything. Even if I put the abstract keyword, nothing, and there's no, if you notice, there's no code block right here, right? I need to make this either public or protected for it to be valuable. So let's make it public for now, right? Okay, cool. Now that I've defined this method, do you see a method body? Do you see curly braces?
No.
What am I doing, right? I'm basically saying that when I use the abstract keyword, I'm saying that this is not a regular method. This is an abstract method that I must override. And override means I must overwrite. I must recreate. I must change it and make it my own. I have to include it in my class. And I have to use the override character and define, or the keyword, and define what that method body is. That's what I mean. Okay? So here's my class. And now I'm going to make another class. Right click. I'm going to go add, new item, class, and I'm going to call the first one dog, just to keep with this example. Here's dog. And let's do another one right away. We'll make cat too. New item, class, cat. So dog and cat, right? So I've got my dog and cat classes right here. Okay, let's do the cat first because this is up. Okay, I'm going to make it a subclass of the animal superclass. Okay, cool. When I do that, right, I need to make a cat constructor, right? So public, here's my, I'll say this is constructors, because the cat can also have multiple constructors. It's a separate class now, mind you, right? Here's my constructor, right? And I'm making it of type public, right? Cat with a capital C, and I have to take in a name, right? String, name, lowercase, right? And I have to call my base, and I sent off name to my base constructor, right? Make sense? Because I basically take name into cat, and I got to send it into my superclass. Okay, cool. All right. And now, hey, wait a minute. If I say save, right? How come it's not forcing me to use my method? It should, right? Well, here's where I can choose with the abstract keyword to override it or not. So if I look at it, I say like this. I say, and this could be because speak will be a public method. Here's all my public methods, right? Let's instantiate the class cat without defining in here a public abstract, a public method based off the animal abstract string method speak. I don't have it. I haven't defined it yet down here, right, as an example. But I want to instantiate it anyway, see what happens. Can I do it? Okay, so I say, well, my cat is of type cat, right, and is equal to a new cat. And her name is, I don't know, Tiger. There we go. Tiger the cat. Right? Very common name, by the way. And you know what? I want my cat to kind of, I want to build this thing. I want to not run it, but I want to build my solution. It gives me an error. Right? What does it say? It says, does not implement inherited abstract member, right? Speak. It forces me to implement that member. Even though it doesn't give me code hinting, right away, I didn't give it a chance to, right? I went and created it really quickly. If I go back to cat, right? Look what it says. It underlines this thing. It tells me where my error is, right? I've got my base name here as an example, and it underlines cat. It says, hey, you try to inherit from animal. That's cool, but you didn't implement the method. I must override an abstract method that's been defined, but not or been mentioned. The header has been defined for the abstract method, but the body's never been defined. I have to do this now. So now I go like this: public override, right? I'm going to return what? A string, right? It's going to be called speak. Look at it. There it is right there. Speak, right? And look what it does. Automatically gives me a stub that says throw new non-implemented exception. We don't need to do that. That's just a stub that we get. And I want to say console.writeLine. It's going to speak, right? Let me see if that's correct, actually. Is it a string that we return? Yeah, we do. And it does, it returns what we're going to return. Okay, that's good. We'll do that. Return meow, right? Which is a string literal. Okay, it has to return a string. Make sense? So now this little underline that says that I'm not implementing it. I did. I overrode it, right? I'll save all of it. That should take away my error. When I build it now, let's just build the solution. Let's see if I get that same build error like I got last time without my system crashing. How about that? Build. Build succeeded, right? Takes away that little underline. IntelliSense didn't have a chance to catch up. That's why sometimes it happens, right? Okay, cool. I've done this. This is kind of cool. And this looks exactly like what I want to do for the dog. Let's do the same thing for dog. In fact, if anything, I'm going to copy and paste everything here except for this. So I'm just going to take all this, right? I'm going to copy it, go to dog. I'm going to inherit from the animal class, Superclass, right? And inside here, I'm going to go bam, change this to dog as an example. And instead of meow, I want to say, woof, right? So I've got a dog class and a cat class. They're derived from the animal class, right? The animal class has an abstract method called speak, right? And when I go into my program, right, which is right here, my cat, her name is Tiger, right? And you know what? I'm going to make my cat speak. My cat dot speak, right? And dog is my dog, right? Is a new dog class, and we're going to call him Conan because he's a dog, a tough dog. He's a dog from hell, right? And my dog dot speak. There we go. That was just a little bit of stuff to wake you guys up a little bit. Come on. And of course, we need some kind of stuff to stop me. So I'm going to go console.writes. God, I'm doing this a lot. And you know what? Let's do a couple of them. Console.writeLine. And we're going to add in some separators. And then we're going to go console.writeLine. Say press any key to exit. And we're going to do a console.read key. Nice and easy. And I'm going to run this thing. And I got nothing. Press any key to exit. You know why? I asked it to speak, but I didn't assign it anywhere. So what I really wanted to do is go like this. Console, because it returns string. Console. It did return the string, but it went to the bit bucket. Write line, right? And I'm going to do one of these where I say, I take the value that's coming back from speak and throwing it to the command line, right? And I want you to tell me if you're confused. And is there another way I could write this that's different than this? And would this confuse you if I wrote it like this? Meow and woof, right? Let me just highlight that so you guys can see it. because I know some people were going to go, what the hell? What is he doing? How come he did it that way? What does he mean? Right? Let's show that again. Look. Here's Tiger. Here's my Conan. Right? Here's my cat speaks. And my dog speaks. Except I do it inside my right line. I call the method inside my right line for speaking. Are you clear about what this does? I could have made a variable, a couple of variables. Like, for example, I could have said something like this. Right? I could have said string cat speak. Right? And string dog speak. Right? I could have done that. And then I could have said this in 2 lines. I could have said cat speak local variable is equal to my cat dot speak. Right? And then I could have outputted cat speak. Right? That's also the same as what I did over here. Let's do the same thing for that one. So I want to say dog speak, the same thing, but with an extra variable in play. My dog dot speak, right? And here I'm going to just put in dog speak as a variable. Same thing as I did before, right? One is using an extra variable to hold what I get from this method, right? This method assigns a string to cat speak, and then I write it out. Or I can just write it out straight. Both methods are the same. You might see it done both ways, by the way. Which one is clearer for you? Obviously, this one probably would be. Right? I have a cat, I have a string, and I hold my string in there. Because why am I doing this? Why am I doing this assignment? Because if I go to my dog and cat, let's go to my dog. Look, it returns the string of woof. Right? I can even make it even clearer. I can say, the dog, right? What about if I did something like this? So this dot, here's my speak, this dot, my name, right? So I'm taking in the name of my animal, and if you notice, I'm trying to get my dog, to access to this name variable. But can I access my name variable, the one that makes it speak? The actual name, can I do anything with it right now? Because if I go back to animal, name is private, right? It's private. So the only way I can access this private method is to use this public property name. Okay, how do I do that? Let's go into dog. So I know I need to use this dot something. Let's go like this. This dot name, capital, right? So let's say the dog's name was Conan. I'll say Conan plus, as a concatenation, says wolf, right? Conan says wolf. That's what it'll say. And you know what? I'm going to do the same thing for the cat. The cat says meow, but I wanted the name of the cat, so it's this dot name, right, plus says meow. Okay, now if I go back to program and I run this thing, it says the tiger says meow and Conan says wolf. They're a dog and a cat. Make sense? So again, recap. Abstract classes, what they do. We can never instantiate an animal class. Let's go back to a program, and I want to instantiate an animal type class. I want to say animal, my animal, right, is equal to new animal, which the name is animale, right, which doesn't really exist, right? Okay, whoa, I'm getting an underline. What does it say? Cannot create an instance of an abstract class or interface. Why? Because abstract classes can never be instantiated. They're just blueprints for other classes. Yeah? Get it?
Do you have a constructor for the abstract class? Because it cannot be
Instantiated, but the superclasses use it. The superclasses use the constructor to set, in this particular case, the name, the subclass uses the constructor to set the name of the private variable underscore name, which, by the way, we don't have access to it in the dog class. If I go this dot underscore name, right, I don't have access to it. It doesn't exist. It's a private property of the animal superclass. The only way I can assign the name to my animal is my get accessor, or my set accessor method. And there is no set accessor method. It's a read-only property, and the only way I can do it is through the constructor. The constructor takes in the name and sends it to the base class, right? Which is the animal class, right? And when the base class receives it, it assigns it right here, right? It assigns it right here. This assigns the name that I take into the constructor. This is my constructor. It assigns it to my private local variable or my private instance variable underscore name. I do that in the constructor. You can't set that variable, that data to send to that variable in any other way. There's no set accessor method.
Okay, it's just replacing the set accessor method.
In the constructor. Right? I could have put it here, right? And then it would have been a public getter and a setter. But this way is a private setter and a public getter, and the only way you can set it is through the constructor.
Only two valid ways for.
That's right, for the subclasses. Again, you might say, "Hey Tom, it makes no sense. Why do we have these silly things, these silly constructs called abstract classes?" Because of control. We can create a lot of control. We can create very complex programs when we start doing abstract classes. We can start defining the blueprint for the class, and other classes will have to derive from them. Okay. So we've hit this one, right? So we know about this stuff. And let's think about some other stuff we can do. This is some other examples. Multiple inheritance. When I hit multiple inheritance, I sometimes want to use something called interfaces, which I have to talk about today as well. Okay, we talked about abstract classes, and unfortunately for us, when we say multiple inheritance, we cannot use, there's no such thing as multiple inheritance. I can't inherit from two separate classes, right? I can only inherit from one class. Right now, that would be called the superclass. However, we can use something called interfaces, implement interfaces, in addition to inherit from a class, to create more complexity for us, for our programmers, to make you all crazy, right? That's what we're doing, right? No, we're using it for that we can create more complex structures. That's what we're doing, okay? So I use in interfaces, right? Again, if I look at interfaces, in this particular case, this is called, we use the interface keyword with iWorkable, right? iWorkable. Once I use, my workable is the name of my interface. And I create a string, if you notice. This is a method, I mentioned a method called work. Right now it's part of my interface. And it says in abstract class, not all methods need to be abstract. Right? In an interface, all methods are abstract. That means if I define a method in an abstract, inside of an interface, they all must be overridden. Right? As opposed to can be overridden. Let me go back to the example here. So if I go back to my animal class, I have an abstract method called speak. But I'm going to make another method in here inside my my class. Here's a non-abstract method. It's still a public method, right? Just to extend this example, it's not a public. It's a public method, but my public method is going to be called. It's not going to return anything. It's going to return void, right? And it's going to be runs. We're going to call it runs with a capital R, right? And I'm going to define the body of the method like we normally do, like this. So I'm going to say this. I'm going to say console.log, right? And I'll say I'll put some kind of interpolation here, right? Conan or whatever it is running, right? This dot underscore name. I have access to that here at the superclass level, right? Console.writeLine is what I should be putting in because I'm thinking other languages. Okay, cool. So I've got a method, a very simple method. It's not abstract, right? It's not abstract, which means I can inherit it right away. It's already written for me, and that means dog has access to it, right? And so does cat automatically. And I don't have to write it again. I don't have to overwrite it. In fact, I can't overwrite it, right? Unless I use the virtual keyword. If I say public virtual void, right? That means I may override it, but I don't have to override it. Abstract, have to overwrite. Virtual, have a choice. Let's see how that works. So if I build it, I'm going to build the solution the way it is. Let's see if I get any errors. I don't, right? Let me run this thing and see what I still get. I still get this. That's cool because I haven't changed anything. Now let's make it run. So not only does the cat speak, right? But I want to do my cat dot runs. And I want to do the same thing for my dog. My dog dot runs. All right, okay, it's a method that I'm using. It says virtual in front of it, right? But I haven't done anything virtually with it. Hey, cool. Tiger says meow, Tiger is running. Conan says wow, Conan is running. Right? Nice and easy example. Okay, the great thing about making it virtual, if I say virtual, is I can override it. I don't have to. So here in the cat, or in the dog method, I can say public override, right? And of course it's going to be of type void, right? And the name is runs. Look, it even prompts me for the type I want to do that. And I say, look, I'm calling the base method runs, right? Here's my base method runs. But I can, when I override it, if I take this out, right? And I just want to put in here console.writeLine, and I'll say something like, my dog is lame and can't run, right? And instead of my dog, let's put in the name of the dog, right? So I'll say, because it's a special, all dogs that I have in this particular case, Conan, right? And I'll say, this dot name, right? I have a runs method that the cat is inheriting, right? Let's see if I can build this thing. Can I build it? Build succeeded. Let's see if I run it, what happens. Hey, Tiger says meow, Tiger is running. Conan says woof, Conan is lame and can't run. Right? Right? So what am I doing? I've introduced two keywords here. Abstract, must override. Virtual, may override. You can choose to override it or not. Right? Okay, cool. I need to put those two words in place because now we're doing interfaces. And interfaces, like we talked about, has any kind of thing we establish in an interface is a different structure. So we've got abstract classes and interfaces. And interfaces, you must override all the methods that are inside of interfaces. Okay, I must override. Let's look at this. Here's my employee, in this particular case, right? And the employee is inheriting or implementing the I workable. See the I in front of it? This is a very common convention, right? We put the capital I in front of the interface name to tell you that it's an interface, that it's not a class. Okay, that's the reason why there's an I in front of it, here and here, right? Actually, class employee and class animal are both inheriting, right? And these are superclasses. These are abstract classes, by the way. Or this one's not. This one's an abstract class, and this was a concrete class, right? But the abstract class animal is inheriting this I workable interface. And if you notice back here, it says that there's a work. Work has to be overridden, right? So here is where I override work, right?
I workable isn't a superclass?
It's not a superclass. It's an interface. And an interface is like a superclass because we can't have multiple inheritance. I can't inherit from two classes. I can't say I'm an animal, I inherited from animal, and I inherited from alien, right? I can't inherit those two things, an alien animal, right? I can't do that. But I can give an alien interface. Maybe the alien infected the animal, right? And that's kind of what we're doing here, yeah.
Where would you write the interface program?
Yeah, I'm going to do that right now. We're going to write an interface called I workable, like we said, right? And if you notice, it has to do this work, right? For example, my employee can do work, and my animal can kind of do work, but let's just look at that for a second. So think about something that we want to implement, and it's above the animal superclass, right? So right now, the animal class doesn't inherit from anything, right? I want to create a new structure, so I'm going to go right-click, add, and new item. And now there's different ways of doing it. I can go class, and I can go interface. Interface is what I want to put in there. And if you notice, interface 1 is the standard, is capital I, right? So let's say there's something that I want my animal to implement. Like, for example, eats. It's the I eats interface, which makes sense because all animals eat, right? But not only does animals eat, humans eat too. Humans is a superclass, and it may be an abstract class of us, right? Animals and humans are different things, right? They might be two separate abstract classes, but they both eat, right? Which means they can inherit the interface I eat, or I eats, if you will. Let's try this. I eats, right? Add. So here's my I eats interface, right? And what I'm going to do with this interface, right, is it actually defines a method called eat, right? It's the eats method, not I eats, but just the eats method, right? Now there's a problem here. I have to kind of sign it with public, right? And if you notice, it says method must have a return type, right? I'm going to return void, right? The eats method. Okay, I'm not signing it with anything. I'm not adding a body to this method at all, if you notice. The method body is empty. I don't define it here again. I define it in the receiving class. Okay, now so here's animal. It's going to implement the I eats interface, right? What that means is, in order for this animal class to be valid now, I have to have a public method, right, called eats. I have to have it. It's required because all methods that I establish in interfaces are abstract methods by default, and they all have to be overridden. Okay. So here I'm going to call this another public method. And let's do it without. Let's say if I don't make it happen, but I made it happen. I put it as part of my class. I'm going to save this thing. And now what I'm going to do is I'm going to build it. I'm not going to run it. Let's see if I get a build error. I do. It says the modifier public is not valid for this item. Let's take a look where it is. That's the first issue, right? Okay. I'm going to fix that. Okay. And let us save everything and build it again and see what the problem is. Okay, here is another error. Animal does not implement interface member eats. I'm forcing animal to interface to eats because all animals eat, right? Just like all humans do, right? So now I have to define, in order for make all my animal classes valid, I have to implement the eats method, which is going to be a public method. So here I do it here. Public, if I can spell, public override, right? And if I start looking at it, I say, well, I want to override equals get to or hash. Where's my other one? Void, right? Eats. Can I do this? Okay, if I can, then I say, console.writeLine. I'm going to say the same thing. I'm going to say the animal, whatever the animal's name is eating. Okay, if it's right, I'm going to first, before I run, I'm going to build, see if I get any build errors. I do. It says, no suitable method found to override, right? No suitable method found to override. Why? Right? Because even though I established that it eats, let's go to the example here. I'm inheriting I workable, and if you notice what it says here, I have work, but I don't have to use the override keyword because I'm inheriting an interface, not a class, and that's the difference. If it was a class, I'd have to use the override keyword because of inheriting an interface, or I'm implementing an interface is what it's called, implementing interface, inheriting a class, right? I don't need to use the override keyword. It's part of it. I have to use it, I have to declare it, but I don't have to do this. Let's try this, if this is working. Let's build this one now and see if that's enough. Build succeeded. I'm good to go. Now, to test it, I'm going to make sure that all my animals eat. So my cat dot eats, it's public member, and if you notice, automatically, I didn't change my cat or my dog. I just changed the animal, superclass, and both my dog and my cat can eat. There's other things that dogs and cats and animals and humans can do too, but we're not going to put those in there, right? Because they have to eat, and something has to happen when they eat, right? Let's go on. So here it goes. Tiger says meow. Tiger is running. Tiger is eating. Conan says woof. Conan is lame and can't run. Conan is eating. Okay, cool. What if I made my, before we go for the day, what if I made my animal, instead of it being public void eats, I want to make this virtual, like this. Can I do this? So I have to establish it as a method, right? But I can still put abstract and virtual in front of it too. Let's say it's virtual. So I can eat. Most times it eats, but you know my dog has a problem eating because it has a stomach problem, right? And I'm gonna establish an overridden method here. So I'm gonna say public override string, void eats, right? Look at that. It says base eats if I want to. But instead of that, I'm going to say console dot write line. I'm going to say the dog, my dog, in this particular case, can't eat. Oh, wait. That's my cat. Can't eat. That's okay. I'll do it in the cat. Can't eat. It has a stomach problem. Or because, I'll say she, because she has a stomach problem. Why not? And of course, I'll put the name of the cat, right? This dot name, capital N, which means I'm using the getter. All right. So now the cat has been overridden, the eats method that has a virtual keyword in front of it on the animal side, right? It means it may be overridden, but doesn't have to be overridden.
As you virtualize the eat method, you have to override it in the other objects, right? So can we actually?
I don't have to. I may override it. Yeah, because virtual is optional. I have an option to override. Yeah, so abstract, I must override, right?
So can you also use abstract over it?
Yes.
And make it.
Yes. So let's try this way first. So here I'm going to run it, and it says says meow. Tiger is running, but Tiger can't eat because she has a stomach problem, right? Conan says woof. Conan is lame and can't run, and Conan is eating, right? Okay, cool. Let's make it like you said. Let's make it so that I must override. All right, I must override. So I go to dog, I go to animal, and instead of public or virtual, I use abstract. All right, here's my abstract class, right? And now I have to do it, right? Which means if I make it abstract, why would I define a body? I shouldn't, right? So if I define it as abstract, I'm gonna do one of these and kill this, right? So now it has to override. So now when I go back to my my dog, I have to do another one over here, right? Because all of them have different ways of eating, right? Let's say, and it's void. And if you notice, eats comes up, and it does this non-implemented thing. And I'll write down in there, console.writeLine. It's going to eat. Conan, whatever my dog's name is eating, right? This dot name. Okay, and now it's the same thing. Conan is eating, and so on, right?
For virtual, do you have to have a body block?
No, you can't have a body block. Like if I look at for virtual, I have to have a body block, or I can't. Yeah, if I put virtual with nothing in there, it'll give me an error. Like So let's look at some examples before we go, just to go on. These things should be understandable now for you. Here's this animal, the class animal. If you notice, it's got a public, unfortunately it's cut off here. Abstract, it means must override. And if you notice, here I override the work for both my animals, which is of type dog and cat. Right? And that's how we create and use interfaces. So I'm not going to do this anymore up to here. I'm going to stop here for today. But what I want to talk about is just, so let's just talk about what we've talked about today. All right, so the first part we dealt with properties, right? And the difference between properties and instance variables. This part 2 of this series, right? We talked about abstract classes and interfaces. When we use the override keyword, we're able to change the original blueprint of the class that we inherit from, and we can customize it or specialize it for our subclasses. All right, that's what we're doing. In fact, what this is called is polymorphism. We're able to use the same methods, and we're able to morph or change what we're getting from the superclass and customize it for our subclasses. And that's why I wanted to leave it till today. I wanted to talk about abstract classes and interfaces today, and in the future, when you do your next assignment, you'll have some piece that may be abstract that you must override, and other pieces that are virtual that you may override. Okay? And we'll leave that for today.